Time to learn how to program your DX27. First thing you do, you press function and make sure you press init voice, and then you press yes, and it asks are you sure, and you press yes again, and you go into the edit mode, and what you see on your screen depends on the blue writing on top of your keys. Now the init voice gives us a sine wave, very dull sound that you can hear, at normal pitch. One operator, the carrier, set to ratio 1, and the envelope set to just turn it on and off like a switch when you touch the key. So what we're going to achieve this afternoon is we are going to play with just two operators, one carrier and one modulator, and we are going to start with the envelope for the carrier. Okay, so what we do is, first of all, we press the output level. We see it set to operator 1, and we raise it to 99, which is the maximum. Okay, so that gives us the loudest carrier. Now it doesn't really matter too much what algorithm you have. You can use any of the algorithms except algorithm 8, because all the algorithms have at least one modulator modulating a carrier. However, it's normally set to algorithm 1 when you do the init voice, and so we will leave it there. So now we have our ADSR. So we press the AR button, which is button 15, and we see that it is set to 31, which is the maximum value. So the maximum value on the ADSR is equivalent to having maximum sustain clockwise and your AD and R set counterclockwise for minimum delay. But it's sort of different in the DX. The maximum value of the number is actually minimum time. So basically you're going to pull it down. Now when you pull down your AR as shown here, you actually have to pull it down quite a way before you can hear any delay. When it gets to about 14 or 15, you begin to hear a slight delay, and we are going to pull it right away down to 10. So you can hear a little more delay there. Now, in order to show the decay, we're going to have to pull down the sustain level. Now the sustain level in a DX27 is called D1L or D1 level, and its maximum value is 15. So when we pull that down, listen to how it sounds. After our slow attack there's a sudden drop in volume. And as you can see, we have to come down fairly low in order to begin to see an appreciable change. So we leave it there at 9. Now we can extend the decay by pressing the D1R and pulling that down. Now we have to once again pull that down a little way before we begin to hear. But once we reach about 16 or 15, we begin to hear a difference. We'll just pull it down to 13 so that you can hear it attack and decay and sustain. Listen to it now. So you can hear a definite rises to a maximum and drops back to a steady level. So now we are going to add a little bit of release. Notice what happens with our release when we pull it down. We have to pull it down fairly far till probably about 5 or 6 to hear it sustain or release after we take our hands off the keyboard. So now we have that's our volume envelope. Sound rises slowly to a maximum, drops to a lower level, and then when we release the key, drops to 0 once we release the key. Now let's introduce some FM modulation. We switch to operator 2 and we go to the output level, which is button 20. So we see that the output level is 0, which is what to be expected since we were only using operator 1. So we're now going to modulate operator 1 by operator 2. So when we bring up the level, notice the sound gets brighter. That's maximum there. Okay? So let's leave it about $89 for a nice bright sound. Now what are you actually hearing there? That sound is only being treated with a volume envelope. You're getting no timbre change. No timbre change, only a volume change. What happens now if we copy the envelope from operator 1 to operator 2? To do that, we just go back to operator 1. We press the EG copy, and then we touch operator 2's button here, and it should be done. Now listen to it with both of them having the identical envelope. You're getting your usual cat meow associated with your low-pass filter from your analog synthesizer. But our synthesizer doesn't have any filters at all. This is the reason why FM is a little different than normal analog synthesis. But you can get the same kind of waveforms. Now suppose we decide that we want to change the envelope of the modulator. If we change the envelope of the modulator, we are going to get a slightly different timbre change, but no change to the volume. So let's do that now. Let us switch to operator 2. Press the attack rate, and we will make it a little slower. So let's bring it down to 6. Now what does it sound like? There you can clearly hear that the timbre change is stretched out over time. So it's slightly displaced from the volume envelope. So you can have some fun playing with those and see what sort of effects you can get by displacing it even more. But it has the biggest effect obviously with the AR. If we go to the D1R and we put that back to 31, we hear the little pit there when it drops instead of having the decay. Or we can go to the AR and speed that up too. Notice? Okay, so we can see that here the two envelopes are not identical, and time-wise the timbre change does not coincide with the volume change of the carrier. The next thing we can play with is the frequency ratios. Right now the frequency ratio of the modulator is 1 and the frequency ratio of the carrier is 1. So we're essentially modulating the carrier at the same frequency, and that's what we're getting. We're going to leave the carrier at 1, and we're going to shift the modulator frequency ratio with respect to the carrier so that the sound remains tuned to normal piano semitone. So if we raise it to 2, that was 1. That was 2. That's 3. That's 4. Now if we go higher, it's going to, let's go to 8 just to show you. That's 7. Right, it's a higher pitch. Now if we come all the way down, say to 0.5, that's quite a nice sound already, and we're only playing with two operators. If we set the ratio to something other than, say, 0.5, 1, 2, 3, which is a direct relationship between the two, suppose we set it to 0.78. Now we're introducing Inharmonics. So anything other than a normal, nice, even division between the ratio of the carrier and the modulator is going to produce these Inharmonics. Here we have 1.73 to 1. So if that's your thing, you can go for it. And when we get to the higher ratios, we get higher frequency partials. If we go to lower ones, like let's go like something like 0.87. Now you notice that even though the timbres, we're still getting that identical behavior in terms of the envelope. And of course you can go back and play with the envelopes some more. If we go back to envelope 1, and we can of course control the attack time. Now remember, this is the carrier we're adjusting. What's happening there? Carrier is coming on immediately. Modulator takes a little while to change the timbre. So you're getting that sine wave ping before the modulator comes in. Hear that sine wave ping before the modulator comes in? And so that's what happens there, because the sine wave carrier turns on and then the modulator gradually rises and modulates it. So that's why we're getting that sine wave ping. Now what happens if we get a direct drop? What is that? That is with no decay. No decay, or very, well, they say no decay. It drops directly from the top right down to the sustain level. Or if we want some decay, we bring it down. Well, I think that's enough for one lesson. Play around with those settings and get comfortable with them. Thanks for watching, and we'll see you in the next video.